This is Glenn Allers with Solar Culture. I'd like to talk to you about a solar greenhouse that generates power, saves water, and increases crop yields. The problem we are addressing is the competition between PV development and agricultural land use. The current approach to combining solar and agriculture is to simply elevate conventional panels above the crop, allowing for planting below, otherwise called agrivoltaics. Unfortunately, this approach is not being adopted. For the energy developer, it increases costs with little financial gain. Farm income does not justify the added cost to the PV installation. For the farmer, his job is made more painful working around a PV array. So it's a lose-lose situation for the stakeholders. Our solution is to focus on covered agriculture. Covering a crop reduces evaporation and increases water use efficiency by up to tenfold. It also increases crop yields. Best yet is that covered farmland rents for a few $1,000s an acre instead of a few hundred. The main obstacle for the grower is the capital expense of adding the crop covering. But energy companies are really good at providing capital, provided there's a power purchase agreement and a lease agreement. So the PV developer is happy with a PPA and a rental income. The farmer is happy with higher yields and saving water. It's now a win-win proposition. For this project, we built a demonstration greenhouse for our new semi-rigid hoop house solar panel. We modified an existing structure by installing curved hoops and a plastic covering. We then mounted our semi-rigid panels to the south side of the hoop house roof. The panels are made of a lightweight semi-rigid plastic and are about 3 feet by 6 feet. Quarter-cut bifacial silicon solar cells are spaced out across the module to allow for flexing without cracking. Installation can be done easily in 10-foot by 6-foot sections because of the light weight of the panels. The panels include a proprietary red luminescent pigment that is known to enhance plant growth. The Ready Award provided the resources to do extensive durability testing on the semi-rigid panels and the mounting method. Static load tests using sandbags simulated 100-mile-per-hour winds and allowed us to optimize the mounting methods and the cell layout. Damage to the panels was monitored with IV and electroluminescence to test for cell cracking. After passing laboratory tests, we proceeded with field testing for wind and installation procedures. In the end, we were able to build, mount, weather, and remove panels with no damage to the cells and no power loss. We would like to cover the Southwest with a gigawatt of solar hoop houses, but that will not happen soon. The ideal market to focus on is the thousands of food processing plants across the country. These facilities use a lot of electricity, they're located in agricultural zones, and they pay retail electricity rates, making them an ideal candidate for a commercial power purchase agreement. Our solution adds value by providing what is effectively a ground-mounted solar array that also serves as covered growing space. This covered growing space can be leased out to local growers who then provide crops to the food processing plant. The energy developer wins with both a PPA and leasing income. The farmer wins with higher yields and less water usage. The food processor wins with local crops and local jobs provided. A win-win-win proposition. Our ultimate product will be a solar hoop house package, including the frame, panels, hardware, and engineering. But first we need to build some demonstration test sites from the ground up. NREL has kindly offered space at the wind test site for one of our solar hoop house packages. There's no better demonstration site than NREL. We will work with third-party solar certification labs to provide validation that the panels can last in the field. If all works out well, we will work with our manufacturing partner to add our panels to their UL listing. Commercialization would start with small farmers that need off-grid power for their farm. Once we have this experience, we can move on to connected hoop houses to supply the megawatts needed by food processing facilities. Eventually, we hope to develop a region in the U.S. like Almeria, Spain, that has over 100,000 acres of covered agriculture. The core business of solar culture is glass PV panels for high-end glass greenhouses. This semi-rigid product would allow us to expand into the broader agricultural community. We have a deep understanding of both solar and growing based on our years of working with commercial growers. Our greatest strength is that we built an extensive network of partners in the farming and solar communities that make us uniquely qualified to execute on this project to combine solar with covered agriculture. I thank you for the attention.